more bar. Okay, ladies and gentlemen, I got the camera to the right side. I'm left-handed. Hopefully you'll see everything I'm doing with it. So first thing I'm gonna do is I'm gonna loosen all the bolts that are on the top. I'm gonna wear some gloves. Be right back. So these are really strong gloves, but I double them up when I'm working on high voltage. The voltage on this battery bank is significant, so I'm going to wear rubber gloves on top of rubber gloves. These are not electric gloves, but they're really heavy duty mechanics gloves, and they don't break for nothing. They're really strong. That means they got a good dielectric resistance. So from here forward, no metal stuff on top of the battery pack. We unplug our connectors and the battery pack comes apart. No sense in even using these until we're ready to put the entire cover back on. You know, the biggest problem with not putting the cover on is then you could short circuit this terminal. If we put this negative attached to this negative, the battery will short circuit this battery here. So if you drop it right now, it's shorted between these bars, which is going to be removed. So you just loosen all the bars. Loosen more bar. Holy cow, it's got a lot of power. That's what I'm talking about. You got to be incredibly careful with this. So let's disconnect this circuit here. These are copper bars, so you can sell them as copper. They're coated with tin. So they look shiny, but they're not metal. I tested them. They're copper. You throw that in the copper pile. These bars in the back doesn't matter unless you're going to be separating them, which I will be eventually separating all of these batteries. Unless I can come up with a way to pay for these. Hopefully YouTube gives me a couple viral videos, and then that would cover these batteries, all of the batteries. I'd love to keep them all, but taking those back there apart just yet isn't too important for somebody else. But like I said, I'm going to be disassembling these batteries more than likely, so I'm going to be taking apart the ones that'll be sold first, which would be the two 24-volt packs. I'll be taking this one out first, which I will just take the rods out. There's 4 rods, and then this pack here. But I don't want to just leave it out. Like if I start breaking down this pack, I'm going to sell the whole pack for sure. And then what I'll do is, after I get everything paid off, I'll get another battery and then sell them again, etc. We'll keep selling these in the future. I won't be using the pin terminals here because they're designed for 300 milliamps and most BMS systems will exceed that. So if you run more than 300 milliamps into this circuit, even if you replace the plug, okay, even if you replace the wires on this plug, you cut these out, resolder the plugs together, these wires in here are the same size, and they run from here all the way over to here underneath this plate here. So what I'll do is I'll make a battery management attachment that corresponds with whatever. Let's say you've got a 24 volt battery, it's 6S. I'll put a 6S male connector, a 6S female connector coming out of each side, and then they'll be balancing themselves. Let's say, we do that. You can run these in parallel, and I'll put fuses in here as well as, fuses on, there'll be fuses on both sides of the circuit as well. And the wires will have independent wires going to each terminal. Unlike these little circuits here, you won't be able to balance all the cells with these circuits unless you use the original battery management system. And the wires are so thin that you can't use those wires. I mean, they're just so thin because you can't run amps through them. So, like if you went with a Batrium battery or whatever company, any Chinese knockoff, whatever, and you want to run it as a battery management system, it's definitely going to be beneficial for you to go with these, because I'll have a balanced circuit on one side and a female circuit on another side, that where you can attach the balanced circuit. And then you can just go get you a good 6S hobby shop plug-in for $20–30. Plug it in, you'll be able to see it digitally, and you'll be able to balance it digitally. Because if you have a small battery bank, most people's going to have smaller battery banks. If you have a small battery bank, it's going to drop the battery in and out. Depth of discharge is going to be way harder. You're going to be charging a lot faster, and that's going to be changing how fast it charges on one cell per other cell, etc. And then you'll have to balance them regardless. And if you buy a gigantic pack, it doesn't balance. It doesn't get out of balance as fast, but it still will. So I'm gonna go ahead and break this apart, but I'm still gonna wire this up, and then when I'm selling them, I will write how many kilowatt hours is in the battery pack and how many miles the car had, if any miles. Let's assume, I'm buying them used as cheap as possible. But you will know exactly how many kilowatt hours are on this, because I've got a discharge testing device that will discharge these from fully charged to completely dead at 24 volts or 48 volts. And you'll know exactly how much power you got. So I'm hoping I don't have to sell these, but when the time comes, I will sell these before, I take money out of the pocket to pay the credit card on it. So we've got these broken down and separated. Here's the positive and negative terminals. Positives on the left, negatives on the right. This is a 48 volt battery bank. I'll show you right here with my meter. No metal in the back. Never put a piece of metal on top of this battery. Never put a piece of metal on top of the battery. This battery is 45.9 volts. Its nominal voltage is 44 volts. And that's a 48 volt or 44.4 volt battery. This is a 24 volt or 22.2 volt nominal battery. Now this battery has 22.94 volts. So that's excellent. There's a 45.9 volt battery here. So this battery and this battery is pretty much in balance with each other. 45.9. Now, if you didn't know which terminal it was with this specific meter, it shows you negative voltage if you reverse the leads. So I'm going to take the negative lead, I'm going to put it on the negative terminal. The positive lead, I'm going to put it on, negative lead, I'm going to put it on the positive terminal. And the positive lead, I'm going to put it on the negative terminal. And this one shows you a minus sign right here on this battery here specifically. So if I could, right there, there's a negative sign right there on the meter. But all the batteries are going to be wired up pretty similar, and we can move forward. Now, what I'm going to do is I need to find a hammer as well wherever I put my hammer. So I'm gonna cut this first, because how they done this, they took copper sheets and they cut it, and then they timmed it on the ends. So this has got solder to hold the copper sheets together. You can see on the side it has a copper color look. So what I decided to do was take a pair of sheet metal snips. These are Midwest, they're pretty good, they're strong. And you'll just cut it where it's flat. And then you'll take a hammer and you'll beat it out flat. And I'll go get one. I don't know if you could see that over there. So you cut it and then you beat it out flat. And then you just cut this right here with a knife, and then you got these. And whenever you beat on it, it's gonna change the way it looks a little. So this is the negative terminal. It's our first negative terminal. And if we go along one piece at a time, everything will work out well. And these are the fuse links that I like to use. Technically there's better ones, but this will be sufficient when you're running a 48-volt battery bank. And this one is a 48-volt battery bank. But it's not just a small bank. You'd have to have literally several batteries in order to provide, you know, the adequate number of power, amount of power. So this is 12 gauge wire. I'll put a 40 amp fuse in there. You're gonna say that's double the rated power for a fuse. Well, I'm doubling the rated power of the fuse, not because I'm concerned about it, you know, popping early, because it won't. I'm putting a bigger fuse in there because I want it to have extra leeway. Now, if it starts hitting like 40, 30 amps or so, that's not going to ever happen with my system because of the way I calculate it. So you have to calculate how many amps your fuse should be. But if you're going to put this together, you should correspond with the exact size wire. Now I'm going to use 40 amps because I don't want voltage drop, because I've already got a thin wire. So, but when I put this all together, I'll have a current of 8 multiplied by 20 is the amount of current that's going to go through here. The total capacity, and that'd be 160 amps, and I'm not going to hit 160 amps. So 8 multiplied by 20 is 160. You've got a 40 amp fuse that gives you a little bit of leeway, but let's say you do have a heavy short circuit on a battery. That battery is going to either pop that fuse almost instantaneously because one of them gets short circuit. If it gets short circuit, it's going to spark and power fly out. But you don't want the power to continue to drain power out of these other batteries. So you want to fuse at least the negative or the positive. Both is better. I'm just doing one. So I strip it back. And we can hook up. You also want to strip this other side. How you're going to do it. This is how I'm going to do it. So this will connect here. We'll solder that up, and we're going to connect the 24 volt negative directly to the same terminal. We're going to run it across. All the negatives will be soldered all the way across together, and then the positive on the 48 volt side of the battery will be where I put my fuse. Now this battery is a 24 volt battery, and there's another 24 volt battery at the very end. What I'll do is I'll take number 6 gauge or 8 gauge wire, I'll run it across through here all the way to the end, unless I'm going to draw a lot of power through this. Let's say I'm going to pull 300 amps through this battery pack. Well, I'm obviously going to need 300 amp wire and a 300 plus amp fuse, like 350, 400 amp fuse, something like that, or even a breaker that is matching. So, but it needs to be right here on the battery, whatever you do. That's why I'm putting fuses on these batteries, because these batteries can unload a gigantic amount of power in a very short period of time. So you've seen that with, you know, when I shorted between this terminal and this terminal. So that's 2 cells it went through. So as the second cell, as this first cell between these is 3.3 or 3, whatever the nominal voltage is. And then right here is the nominal. So you'll have, you know, right here between those two is quite a bit of power. And you see a very, very small part of the battery. So I'll check the balance on this, make sure it's correct. If it's not, I'll balance the whole battery and get it back in balance. Now, whenever I'm tightening these down, so when these do get connected, I want to make sure that these stay separated. So when I get this soldered and done, I'll put the cover back on, and then I should move on. I should leave this cover covering it just for kicks. It's not even lined up correctly, but it doesn't matter as long as it's covered up a little bit. Now, how I'm going to do this is, if I ever wanted to add another battery bank, I'm going to leave enough extra on the end. I'm going to leave enough extra on the end to provide an additional circuit. So I could use a split bolt to tie in another battery. But since it's not likely that I'll be getting another battery, I'm just going to leave it enough to connect a split bolt, and then I'll tie it up with some type of insulator. So I'm going to solder these connectors here, and this will be my first circuit. I'm going to leave plenty on the right, and I'm going to leave plenty on the left. And then I'm going to want to pull my circuit all the way out to where I can fold it in here. And I'm just going to lay it on top of the next one. So I want to fold it in there. And then I'm going to take channel locks. Where's my channel locks? I'm going to grab it. I'm going to pull the wire all the way back, and then I'm going to pinch it in. Pinch it and push it. Now, we pinched it and pushed it, and we've got these tabs on this side, and what I want to do is go ahead and clamp these wires. Don't have to clamp it a lot, just clamp it, and you want to get it in the center. And now we've got our circuit clamped, and we can solder the wire internally, externally, and all the way around. That way we've got the ability to have a solid connection that isn't going to come off. And since this one's going to be bent up again later, we're just going to bend it up a little, about where we was going to bend it in the first place. So that way it don't fall off. I'll get a light. Now, I don't want to melt any plastic, but we are going to have solder dripping down on the side of the battery if we don't have something like this. This has metal terminals, metal weights kind of, and you just take them and droop them over, and then you just let it droop over, and then we're going to reconnect this here. We just need to be able to add solder to each side, and then we'll be good. Now let's go down. You take your pliers, just attach it, not squeeze it, but just touch it. Now they'll move the heat. Right. The pliers will be directly to the metal pliers. Hello, ladies and gentlemen. Thanks for watching all the way to the end of the video. There's lots more content coming. Click the subscribe button below. Make sure you come back for more because there's great content always coming up every day in this channel. See you next time. Peace.